Okay, so now let's have more ADTs and data structures. But of course, let's limit them to linear ADTs and data structures for now. So throughout the second part, most of the time when we talk about the ADTs and their corresponding data structures, it might get a little confusing because we don't have a specific name for the data structure like we had for like linked lists and dynamic arrays. Usually, for example, here, the first one we have the stack ADT. Uh, when we just say the stack or stack data type, that refers to the ADT. And when we say the stack implementation, that refers to the data structure itself. So without further ado, the stack ADT is a reduced function or a reduced functionality form of the dynamic list, which follows a last in, first out principle, which means that you can think of it as an actual stack, wherein when we have a stack of boxes, you can't move the bottom box without compromising the stack itself. So the best way to move objects in the stack is always just to move the topmost element. So either put one on top of it or remove the one on top. So that's how a stack basically works. So we can only push an item at the top of the stack, and we can only peek at the last item in the stack. So you can't really access the elements in the middle or even at the end of the stack. And then the pop operation removes that top element. So what's very interesting here is that only one element is, or only one memory location needs to be remembered, which is the topmost level of the stack. And one of an implementation of the stack you may already be familiar with is the program stack for when we call functions in our program. So the last function that is called or pushed into the stack is the first function to finish. And actually, the program stack is an implementation of a stack ADD. So technically, it is a data structure itself. So not only can we implement ADTs through software, we can also implement ADTs or make data structures using the hardware of our computers because the program stack is actually a hardware thing. There is a specific memory location or a specific section of the memory dedicated to the program stack. So visualization of how a stack works can be shown here. So once we have a new stack, we push 10, 20, and 11. We peek at the last element, that's 11. And we go through the operations. It's pretty much self-explanatory. But if you don't understand it, don't be too ashamed. Just, I guess, send me an email and then we can talk about it one-on-one. So the stack is basically just a dynamic list, but we don't need to access the elements in the middle or the specific part of the list. Only one specific element or one specific end of the list is modified. So for if we want to implement a stack in our code, we can either use the dynamic array implementation of the dynamic list or a linked list implementation. So instead of having insert, delete, and access, we just have peek, pop, and push. So the peek operation is basically an access operation that is always accessing the last element. And then the pop and the push operations will be the delete and insert operations. But they would always be inserting or deleting the last element on the dynamic array. And the same goes for the linked list. So when we summarize that, running times for the pick, push, and the pop operations for a stack, if we use a dynamic array, at the worst case is the push operation wherein we need to insert and then the list is at full capacity and we have to reallocate. So that's just one of the few times, or that's just the only time actually that the push operation goes to linear time. But as you can see in general, since for a linked list, uh, we can actually operate on the first element of our linked list instead of the last element and treat that as the top of our stack. Since accessing and deleting and inserting at the start of a linked list is always a constant time operation, since we don't need to traverse the linked list anyway. So, uh, which do you think would we prefer when implementing a stack? So it largely depends on what can your computer do. Uh, Usually, the linked list is one of the better options since it always runs in constant time. But not everything can run a linked list. And of course, the linked list itself, in order for you to store an element, you basically have an additional memory space to use to store the pointer to the next element. So that's another caveat to that. But yeah, that's all for the stack ADT and its implementations using the dynamic array and the linked list style or framework.